All right, so welcome everybody. We're very happy to have Asmae Toumi joining us. Asma is make sure I get this right, Director of Analytics of Client. Was it
Pursue
Client?
Care.
At Pursue Care. I've already said Pursue Care. And she is also a member of the winning team from the 2021. Is it, I don't know how the year round works. Is it the 2020 or the 2021 Data Bowl?
2021.
That's what I thought. So the winning team of the 2021 Big Data Bowl, she's going to be here to talk to us about dealing with tracking data and just kind of getting her feet wet with some new types of data and how to kind of start work with that. So we're really glad to have her in. I'm going to just pass it off to her and we'll get moving.
Yeah, thanks for the intro. It's a pleasure to be here. I'm seeing some people joining from all over, actually. Kingston, Ontario, Greenwood, Indiana, Atlanta. That's really cool. So yeah, so I'm here to talk to you guys about the Big Data Bowl and our process and what I think made us stand apart and how we won it. So let's get started. Can everyone see my slides okay?
Yeah, we can see it in here.
Okay, great. So starting off with, if you're just joining, not really sure where you are in the conference, we're going to be talking about the NFL's Big Data Bowl. And so what is it exactly? It's an annual sports analytics contest that's organized by the NFL's football operations department. And it's a contest in which you could have access to both traditional football data and next-gen stats data to analyze and challenge some trends and player performance with regards to NFL players. Interested people can sign up for the 2021 Big Data Bowl on Kaggle.com. It's now the 4th year in which it's operating, and every year the theme changes, and this year's theme is special teams. Special teams is exciting because it's a relatively understudied field, so definitely check it out. For today's presentation, I'm going to be talking about our process with regards to the 2020-2021 team, which was about defense. It's a 4-month contest, so the data and the theme drops around mid-October, end of October, I want to say, and submissions are due in January. The prize is $100,000 total in total, so that's quite a sizable amount. I have a typo there in my slide, but it is $100,000, and the judges are comprised of a panel of NFL team professionals, so analytics staff for the most part. And what's exciting about this contest is not only the professionalism of the panel, but really throughout the entire competition. Michael Lopez, the director of analytics at the NFL, oversees this contest along with Tom Bliss, who's their data scientist. And many eyes are on this contest at all points during it. So many people have gone on to sports jobs, both in the NFL and other leagues. So when we were joining this competition, our first sort of consideration was, okay, we're interested. Now, how do we sort of set ourselves up for success? And so it really does start with tools, in order to have good processes and good communication. So one of the first tools that we knew we were going to use, starting with the top left, is RStudio. This is an IDE to do our statistical programming and general use programming. Given that we were all RStudio programmers, we definitely decided to stick with just that, but many people do combine R with Python and other technologies. The second tech tool at our disposal that we knew was going to be really important right from the get-go was GitHub. So for those who don't know what GitHub's all about, this allows you to collaborate on code and keep everything sort of organized with timestamps and the ability to revert to previous versions of your project. Zoom was important, not only because we were in the middle of a pandemic that is still ongoing, unfortunately, but we were from all over the US. One team member was in Texas, I was in Boston, Tony was, can't remember, somewhere in the South too. I want to say Texas as well. And Marshall was in North Carolina. So definitely we needed a way to communicate and have that face-to-face contact. So Zoom was definitely instrumental in that, along with Slack. Slack was really important for quick one-off communications, code sharing, sharing of visualizations, and so on. So this is kind of our tech stack and communication stack, if you want to call it that. Another important tool that we made use of, which is Slack, but more specifically, the R for DS online community. So this is a Slack channel, basically comprised of, I want to say now 15,000 people and growing every day. It's a community where our programmers get together and ask each other questions, help get unstuck, and there's dedicated channels inside there, depending on which issue you're facing. And there's one called now SAA Sports Analytics, in which you could see, what are the latest conferences, workshops, tutorials having to do with sports. And there's a few things in there specific to the NFL and the Big Data Bowl. We made use also of this Slack channel to communicate with one another, and we just created a private channel in this community in which we talked about our own project. So definitely check it out. It's good to have everything sort of in one place, all your project specific communication, but also if you wanted to get help or chat with other contestants or other professionals, then this is definitely the community to do so. And of course, Twitter. Twitter is really where I think most of the communication comes in from with regards to the contest itself. I know that the organizers also post on Kaggle.com, but this is a great way to just sort of get breaking news and updates about the contest itself, but it's also an awesome place to talk to other contestants. Most will use the hashtag Big Data Bowl, not only to ask questions, but to also share visuals and share any questions that they may have. And this is cool because you can sort of follow the hashtag and start, building a network, and you never know, maybe you need a team, and that's a good way to find people that would need a team. And so some of the awesome stuff that people post about is code as well, and tidbits. And Namita, who was the former data scientist for the Eagles, dropped this in, and she's awesome, a really great follow. And I would encourage everyone to look at her previous public work as well to get some inspiration. And so someone chirped me today about this presentation saying, is it really going to take 45 minutes to say, ask at Namita and the rest of sports Twitter about the basics of football? And I would like to, because there's a lot to say about how we can learn about other professionals and their public work, but I'll try to be a little more thorough in this presentation. All right, so the first consideration was with regards to the setup, getting organized and getting the tools that you need to be successful. The second big consideration is the data itself and where to even obtain this data. So the whole contest is organized on Kaggle, and in there you'll see tabs specific to details about that contest, starting with an overview. This is really important to read over as it contains many clues and many of the requirements having to do with the contest. And then the one containing the data is aptly named data. And that's where you can not only get a data dictionary where they define what each field and what each data set stands for, but you can also download the data right from there. And there's a code tab, a discussion, and a rules tab that we'll circle back to as this presentation gets underway. What you'll find in the data tab is data from NextGen Stats. So who is NextGen Stats? They're the NFL's provider of tracking data. So tracking data, for those who are unfamiliar, refers to mostly the real-time location data, speed, and acceleration for every player and every play on the field, as well as the ball. So just from that, you can imagine what one season's worth of data could look like. It's very big. And specifically, we're talking about 10 frames per second. So just a humongous granular data set at our disposal here. And from that data tab, you can see all the files attached that you can download. So this was one of my tweets from last year. So we had obtained, 17 weeks of data, so a season's worth of data. And I was just playing around in R. I wanted to get all weeks of data into just one big data frame and realized it was quite sizable, 18 million rows. And it read relatively fast because of a package I used, and we'll circle back on that shortly. But, given that I talked about one of the tools we knew early on we wanted to use, which was GitHub, I wanted to get it up to GitHub. And it was around 3 gigabytes, which is quite huge. So when I pushed it to GitHub, GitHub predictably said, absolutely not, that's way too big. When you looked at the fine print, indeed, 100 megabytes was the maximum size limit. And so I was looking into ways on how to get this data into GitHub. It was more of a stubborn thing, really. It was fine if I just had it locally and just, imported it whenever I needed to. But for some reason, I had made the determination that I wanted people to sort of work off the same data set and have it, in the GitHub repo. So I looked at first the Arrow package, great package, really simplifies the writing and reading of big data. And so I made use of one of the helpful functions there to store it as a Parquet file. And then when you read it back in, it just takes about 42 seconds, which sounds like a lot, but given the size, isn't too big. But really the magic happened as a result of this nifty little package, which is developed by the R open science community. And what this allows to do, which almost feels a little bit illegal, but not really, it's that you can basically tag this data into your repo as a GitHub quote unquote release. So it's there, but not quite there as you would do with traditional methods. So that's a great package if you're looking to put your data up on your GitHub repo and have it accessible to all your collaborators. Looking back on it now, and Tony is, I believe, in the audience. He's my teammate for this year's Big Data Bowl. On second thought, I think a better process is definitely to put this into a database like Heroku, Postgres, and go from there. All right, so those are the considerations really with setup and data, really with regards to just importing it and writing it. I'm going to stop here for just a little bit and see if there are any questions in the chat with regards to that. And looks like there aren't. So I will keep going unless someone raises their hand and wants to ask a question. All right. So consideration number 3, 2 considerations actually bundled in this one, but EDA and feature engineering, right? EDA is one of the most important steps in a project pipeline. It really allows you to inspect your data for outliers, for errors, for things that you might be interested in for your project. So it's definitely a step that cannot be skipped, but thankfully there's a lot of resources that can help us specifically with regards to the NFL Big Data Bowl contest. And then the second one is feature engineering, which is right after the EDA step of when you're actually starting to construct variables that you may use for your later modeling steps. And so, you know, it's quite overwhelming if you haven't worked with this data before, to sort of kind of jump in and try to make sense of it. Obviously, there's some packages and some, you know, good practices when it comes to investigating a data set that you've never seen before, especially a big one. So one of those ways is to maybe slice and dice the data into small chunks to just inspect a few rows or a few variables at a time. You can imagine with the NFL Big Data Bowl, you might just want to isolate one team or one play, etc. But really what's tremendously helpful is to just look at what other people have done. And because of the Kaggle platform, people can submit notebooks at any point of the competition. So if you go right now on the Kaggle website and the NFL Big Data Bowl page, if you go in the search and just type EDA, you'll be able to just filter down the EDA specific notebooks. And I highly encourage people to just take a look at the people's process and code, and maybe even copy paste it into your own console and give it a go. That might help fuel some ideas for you personally as well. The other approach, or an alternative approach that you can take, is also look at Ben Baldwin and Sebastian Carl's amazing NFL FastStar page for their package. So NFL FastStar is a package for efficiently scraping and manipulating NFL play-by-play data. And so what I did pretty early on is go on their Get Started with NFL FastStar page, and you'll see that it's probably a 15 section article going over many examples having to do with both data munging and visualizations with regards to all the helpful functions that they have for both importing, cleaning, and manipulating NFL play-by-play data. So the NFL Big Data Bowl contest is tracking data. That's the main data that you'll be working with. But in the contest, you can make use of any public data that is free and obviously publicly available to everyone. So many people, including us, have made use of the NFL FastStar package and many of the things it offers. So this is a really great beginner-friendly way to just get situated with this package, see what's in there, and maybe even import some of the stuff that it offers into your own pipelines. But there's more. So the NFL, with regards to its R ecosystem, is really, really well developed now. So much so that it's now considered, it's now called the NFL verse. So kind of closely mirrors Tidyverse if people are familiar with that. Tidyverse is an ecosystem of many helper packages. And so similarly, they created the NFL verse, which not only has the NFL Fast Start package, which we've been talking about, but many others that are related to it, like NFL Readar, which is a package for downloading data, and many others like NFL Fourth, which is a fourth down decision calculator. So this is awesome. I highly recommend people to look at all the packages in here, and even look at the source code of some of these packages. You may be inspired by some approaches that they take or some functions that they have, and then integrating them into your own pipeline. And another more chill way to get acquainted with the NFL verse and what it does is to join their Discord. So I've attached a link there if you're interested in getting involved and seeing what it's about. Right, so after some EDA is the cleaning process, and I've attached a dead emoji because the data itself is very clean, I want to say, and definitely usable kind of right out of the box for many applications. But cleaning is unfortunately, or fortunately, if you like it, a very important step in a project pipeline. So there's many things at our disposal to use. So starting with, once again, something that someone else has developed, right? It would be foolish in 4 months to think that you could just reinvent the wheel for each and every aspect. So why not make use of someone's work that they've publicly published and want people to use? And one really helpful package for cleaning is the NGS Clean R package. And it contains a set of functions to clean up and standardize NFL player tracking data, to be specific. So far we've talked about NFL play-by-play data and the packages that exist to clean that and manipulate that. But this one has been developed specifically for the player tracking data. So they have all sorts of helpful functions here that you can make use of right away. And they have some plotting ones as well, which is really helpful in EDA and cleaning, of course. Another thing that is good to look at is also other people's submissions. So other people's notebooks, both from the current competition, ongoing competition, but also old ones, given that the NFL Big Data Bowl has been in running now for 3 years. It's now in its 4th year. There's definitely lots of submissions that you can check out, and even go to their specific GitHub page and see how they've approached a certain task with regards to cleaning the data or manipulating it in any way. So definitely do go see people's notebooks that may be closely related to how you want to approach the problem, but also do check out the official tutorials put up by Tom Bliss and Michael Lopez. They have both R specific ones, and I think Python specific ones, but not that many. So definitely do check those out by Tom, specifically Tom's official ones, because he does a really great job of showing you a project sort of from start to finish. He even includes modeling steps and cleaning steps. So really from A to Z on that. Okay, so, we've been talking about, as newcomers to the competition, that it's really helpful to see what other people have done and to not try to reinvent the wheel and waste time if someone else has put time into it and done it. But there will be certain things, certain steps that you would need to code yourself. And thankfully, there's a lot out there in terms of helpful packages to help you do the manipulations that you need to. Starting with the tidyverse. The tidyverse is an R ecosystem that contains many packages doing specific tasks. So readr is for importing and writing data. ggplot2 is for visualizations. Forcat is for working with factors. tidyr contains just a plethora of helpful cleaning and manipulating functions. dplyr, of course, the greatest of all time, for manipulating data. stringr for working with strings. purrr for functional programming, and so much more. lubridate, really, really helpful because this is spatiotemporal data. So working with time objects is really seamless with lubridate. skimr, an excellent package for continuous EDA and just inspection of objects and data. The janitor package, similarly, for summaries of the data, specifically frequency tables, and just really helpful cleaning functions. And gosh, so many more packages that we definitely made use of. One of the things that Tony made use of in his code is the memoirs or memoirs package. And that's helpful for really computationally expensive functions that you don't want to re-render every single time. So definitely do check out all these packages if you're not familiar with them, because they've been absolutely instrumental in our success in munging the data and feature engineering. Okay, one example of having to sort of build your own functions for your own purposes is my teammate Marshall, who's also in the audience. He built a wrapper to generate fields with many other advantages like horizontal and vertical orientation, access clipping of any yard line, customizable colors. It's really easy to layer your data onto it. You can have faceted fields and integrate really appealing palettes from the R color brewer package. So this was of tremendous use for us, obviously, because it simplified our visualizations. And he put it out there pretty early on in the competition last year. And I think he and my team got really good publicity out of it, but it's also just great to put it out there. And in putting it out there, you make connections, and when you help other people, people help you. So definitely a win-win situation for everyone involved in both creating this and sharing it. Okay, and one of the things that was important for us as we were, developing our own functions and so on, was to try and be as organized as possible. So these are screenshots from our GitHub repo, and you could see, an attempt by us to keep things as organized as possible, starting with our EDA script. So you'll see an EDA as the first string there of the names of our scripts. And some helpful descriptions with regards to what was done last on the script with, I don't know who wrote this passive aggressive message. It was certainly not me, maybe Tony himself, but yeah, definitely good as you're building your own functions and in your project pipeline to just keep things organized into their own folders as to not get lost. Because I think this project, correct me if I'm wrong in the chat, we ended up with maybe 15, 20 scripts, lots of figures. And so keeping things as organized as possible went a long way for us. Okay, so, I think once the EDA is complete, the feature engineering is complete, the fourth consideration is the modeling part. So for that, we definitely made heavy use of the Tidy models ecosystem. So I've been talking lots about different ecosystems, NFLverse, Tidyverse. Well, there's one for modeling specifically, and it's called Tidy Models, and it contains lots of packages that do, specific things in a modeling pipeline. So we definitely made use of it for model pre-processing steps specifically. We ended up using an external package to the Tidy Models ecosystem called XGBoost, and another package for Bayesian modeling. But I just wanted to highlight this XGBoost package. A lot of people have found a lot of success with it in other Kaggle competitions, and the NFL Big Data Bowl is certainly not an exception to that. I think if we were to maybe do it again, we'd use a full A to Z Tidy Models pipeline, given that XGBoost is well integrated into Tidy Models. And so I think I went quickly over that, but why Tidy Models to begin with? It's because it uses a similar grammar to the Tidyverse. So if you're familiar with how the Tidyverse operates, then you'll find that Tidy Models, if you invest the time to get into it, is intuitive in that sense. And it allows you to kind of just stay in one ecosystem for all your modeling needs, really from pre-processing all the way to testing your models and visualizations of the outputs of that model, all in one ecosystem. So if you invest the time upfront to get acquainted with this, then it will really pay dividends. Because if you imagine not, sticking with this one framework, you would have to work with, one or two or maybe three external packages that all come with their functions and their nuances. And so things could get hairy pretty quickly. Okay, consideration number 5 is visualization and presentation. These are extremely important. I'm not going to try to mansplain that to you guys, but it's if your submission, if no one really understands it and is able to make sense of your outputs, then that's not going to be a winning submission. So we knew that we needed to invest a lot in making sure our visualizations are clear, that they're visually appealing, that they're informative, and also tighten up our entire presentation with regards to the submission on Kaggle. And so one of the things that was absolutely instrumental in doing that was using ggplot2. So ggplot2 is in the Tidyverse, so it contains that common grammar that allowed us to make plots iteratively and really rapidly. ggAnimate was really helpful. So what that allows is for making plots interactive, and that's a game changer for football data specifically, right? Because we're talking about spatio-temporal data, so it's really helpful to see, the progression of a play in animated form. And so we really made use of that, along with the magic package that helps tie all these together. And so we were able to generate some animated graphics with regards to that. And these are really helpful to have animated because it helps to just not overwhelm the viewer. They can sort of kind of take their time in looking at it step by step, but also being able to look at it multiple times in that similar non-overwhelming fashion. Okay, another package that we made use of for presentation of results was the GT package. So that one stands for Grammar of Tables, and Similarly to ggplot2 and gganimate, it's really easy to iterate on these tables and make quick changes to them because they do follow that dplyr pipe framework. So starting with just table data, you turn it into a GT object, and then you can customize it at will. So that was behind the tables in our submission. So as you can see, it looks really, professional without that much involvement from the analysts' side. And you can definitely layer in things to make it even more informative. In this case, we layered in sort of a heat map component on that. You could really customize them too by importing team logos. So that's what we did here with our top 10 cornerbacks table. Okay, one other package that we made use of for displaying our results was Shiny. So Shiny allows us to make apps. It allows non-software engineers specifically to make apps. So as data scientists, that's huge. Along with the HTML widgets for our package, which allowed us to bring in JavaScript libraries like data table to display our results in an interactive, attractive way. So we built a Shiny app really in the time span of, I want to say, an hour, maybe a little bit more than that. Our teammate Sydney was in charge of this. And it's really helpful, I think, if you want to win and have a quality submission, to allow users and the panelists to inspect your results. And so Shiny, because it's an app, you can do that. So they can make use of these filtering boxes down here to filter by certain data that they're interested in. And not only that, but there's a great package that's called Crosstalk that when, for example, you filter down your table to just a team or a player, automatically the visualization will also filter down to those specific parameters. So, just going the extra step in making your results available and having them be able to be inspectable goes a long way in building credibility for your project. Okay, so I'd like to just go over, sort of lessons learned that may be helpful for people that are going to participate in the Big Data Bowl for the first time or already participated, but didn't quite finish or didn't meet the success that they were expecting. So the Tidyverse and Tidy models are incredible ecosystems, really, for all the reasons we've been mentioning so far. But I think what really sets them apart from other frameworks is that they're intentionally designed to encourage good methodology and good statistical practices. So the Tidy models package specifically has really sensible defaults modeling wise that you can make use of, especially if statistics is not, your professional background. Presentation matters a lot, both, your submission, but also how you present yourself on Twitter and really any occasion in which you are engaging with fellow contestants or the organizers themselves. So highly recommend people to get on Twitter, interact with the hashtag Big Data Bowl, interact with R4DS communities. You will learn a lot about, how you may improve your visualizations or your pipelines. And for your submission itself, given all the presentation and visualizations ecosystems that there exists in R and Python, definitely do make use of that to build your submission. Tony and I were participating in a book club about the Advanced R book. And I'm going to speak for the both of us. I think it taught us a lot about how to be more efficient programmers. And I think that's important with the size of this data. You're definitely going to want to be mindful of making your functions as efficient as possible, especially if, like Tony, you are dealing with an 8 GB RAM computer. I don't even know how he was able to run XGBoost on the data, but he made it work. GitHub can be difficult to deal with, especially when things are just not going your way. But it is a necessary evil, and really, you know, even with all the headaches, it pays dividends in terms of your efficiency and your potential for collaboration. One thing that we learned last year is to create a package for your project. You know, we found ourselves reusing a lot of functions over and over again. And when that happens, just make it into a package that helps streamline a lot of things. One thing I think that helped us win is our submission was definitely not the most sophisticated statistically or technologically, but you know, we made a lot of effort in making sure the language we were using was accessible, so we didn't have too much jargon, but we didn't dumb it down to the point that judges, you know, didn't see any thought or sophistication in our approach. So definitely keeping things as simple as possible without making it obscure goes a long way. And then designating sort of a project manager for the project. This helped us with just motivation and keeping track of time. You know, you do have 4 months, but you know, there's holidays peppered in and such, and people have full-time jobs. So having someone that could just keep track of that and keep the group positive and motivated is helpful. So I have a bit of a recap of resources that one could use that we've gone over. So starting with a package that helps with functions with regards to cleaning the tracking data. So NGS Clean R, NFLverse for packages that deal with scraping, cleaning, and manipulating the NFL play-by-play data. The Next Gen Stats website is tremendously helpful. It has a lot of articles explaining some metrics. Their glossary is really helpful. It helps, you know, define some of the stats you'll see in the data itself. Online communities, so we've talked about Twitter's Big Data Bowl, R4DS, and the NFLverse Discord. And then I think one that everyone ought to check out is the winners' submissions themselves, and those are available on the NFL website. You could look at their videos, look at past recaps, and also a link to Kaggle winning submissions. So I just want to end this talk really with kind of the most important takeaway for me as I was doing this. You could see a tweet that I posted a year ago now where I was starting to play around with this data and just like counted the number of like events. And like, I like literally didn't know what 75% of this stuff means, right? I'm a hockey gal. Football was something I watched like sometimes, like maybe at Thanksgiving or when I was forced to at bars. But you know, it's amazing what both the R ecosystem allows you to do in terms of like understanding what these things mean as a beginner. But really, I think the most important thing is, you know, when you invest in your community, in your little online community, people will come and help you. And someone made a cheat sheet for me with what everything meant. So definitely do invest in people and building a community around you, because you'll never know how they may be helpful to you and how you may be helpful to them. And so with that, kind of crazy, I got bold, I think, like one night, and decided to cold DM Wade Phillips, a Super Bowl championship winning defensive coach. And because the theme of the competition was defense, I thought it would be helpful to just talk to an actual NFL professional on defense. So I ended up like cold DMing him on like a Wednesday in the middle of a pandemic. And he was nice enough to like, you know, get with us on a call on Zoom. And I think we learned a lot from that conversation. So yeah, thank you guys so much. This was my team. I couldn't have done it without them. And I'll see you guys at the finals in January. Thank you.
All right, do we have any questions? We did have one in there earlier, and I partially answered it. I didn't realize it would just miss the whole question. Jessica had said, "Hi, thanks for speaking. I'm a graduate student at OSU with an interest in sports industry. I'm a beginner dabbling in data analytics. What is some advice you'd give to a beginner data analyst, and what recommendations do you have for program installation, specifically for Chrome OS operating system?" And the second part was the half that I tried to answer, and then it disappeared, the question.
Yeah, no, that's a great question. I know that Python makes it unnecessarily difficult to get up and running with the installation, but RStudio is, you know, relatively easier. I would definitely, there's a lot of tutorials out there with getting up to speed with everything that you need to be up and going. I'm happy to link one in the chat shortly after that for Mac operating system. So hopefully that's the stuff you have. But if you don't for Windows, I'm sure I can find something for you as well. And John, that's a really good recommendation, RStudio Cloud. Yes, because you don't need to download anything. You can kind of just go online and start importing and playing with data that way. In terms of like a beginner data analyst, I think I'm a self-taught programmer, and how I learned was just to look at what I'm interested in, which was sports at the time, and just look at people's tutorials with regards to sports and sports data. That's a low barrier, fun way to learn about statistical techniques and programming techniques that way. And just, you know, try not to overstretch yourself and like try to learn every framework and every method and everything. Just starting small with something specific, and then building on that.
I have a more general question. You know, you're pretty present in the sports analytics world, and you actually work in healthcare. Do you feel that this sort of hobby kind of helps you out, or I don't know if I want to call it a hobby or if that's how you would describe it, but you know, how do you view that and that with your work?
Yeah, that's a great question. I think it's very much a two-way street. There's things that I learned from modeling sports data that I didn't learn working in healthcare, and there's things in healthcare that I learned that I didn't learn via sports. And so because of that two-way situation, everything that I do in the healthcare world also helps me in the sports world, and similarly. So I could give an example: causal inference. It's a statistical philosophy I got to learn through sports, and I ended up, you know, reusing some of the same packages and same approach to my professional work in healthcare. So it's great. It's a two-way street. And I think that's why the NFL Big Data Bowl is such a great opportunity, even if the goal for you is not to end up working in sports. It's spatiotemporal data. There's a lot of fields that make use of that kind of data. And so if you want, once again, a low barrier, fun way to interact with that data and practice it, then the NFL Big Data Bowl is such a great avenue to do so.
All right, well, thank you so much for joining us. We're glad that you could come in here. I like that you talked a little bit about Twitter. Part of the idea of bringing you in here was to talk about the Big Data Bowl. Came from a Twitter feed that I kept referring students to last year, that you had put a bunch of information about getting started with the data set during last year's Big Data Bowl. Well, thanks for coming. I think that we learned a lot, and hopefully we'll have some students putting some projects together.
Awesome. Thank you guys so much.